In our previous period, we were learning to express the rational number or to express the recurring decimal in the form of P upon Q. Already we have solved some examples. Now we will solve some more examples from practice set 2.1. Practice set 2.1, question number 3. Practice set 2.1, question number 1. I will explain how to solve question number 1. Already you have solved in 8th standard also. Classify the decimal form of the given rational numbers into terminating and non-terminating recurring type. For example, now first example is 13 upon 5. So here we have to divide numerator by denominator. In each example, we have to divide numerator by denominator. And if there is end of division, or at last you get the remainder 0, then that is terminating decimal form. If you get remainder 0, there is end of division, then that is called terminating decimal form. And if you go on dividing and there is no end, but one digit or a group of same digit in the question is recurring or repeating again and again, and there is no end of the division, then there is no end of the process of the division, and that type is called the non-terminating recurring. In this non-terminating recurring form, you will get in the question the same digit or the group of the same digits recurring or repeating again and again, and then it is called the non-terminating recurring form. So you can solve it. And also second example, similarly, write the following rational numbers in decimal form. For that, you have to divide numerator by denominator. Now we will solve question number 3. Question number 3 is, write the following rational numbers in P upon Q form. Practice set 2.1, question number 3. Write the following rational numbers in P upon Q form. First example is, third example, 3.17 bar. That means here, digits 1 and 7 are recurring. That means here, 2 digits are repeating. So let x is equal to 3.17 bar. That means meaning of this is that 3.17, 17, and so on. So this can be written like this. That means here 1, 7, 1, 7, 1 and 7, these are recurring digits. So here 2 digits are recurring. So let x is equal to 3.17 bar. Now here 2 digits are recurring, therefore multiply both the sides by 100. So therefore here we get 100 into x, 100x is equal to, now here 3.17, 17. If we multiply here 100, here we get 317.70. Okay. Now, hundred x minus x is equal to, so 100x is equal to 317.70 bar minus x is equal to 3.70 bar. So here 100x minus x we get 99x, and this subtraction we get 314.7, sorry, 340. 99x is equal to 340, and therefore x is equal to 314 upon 90. This is the form of P upon Q form. So this decimal form can be written in P upon Q form like this: 314 upon 99. So here now you can solve, similarly you can solve question example first and second. Now third example we have solved here. You solve first and second. This is for your homework. Now show the numbers root 2 and root 3 on number line. Now this is the number line. Okay. Now suppose this distance is equal to 1 unit distance. This is the origin. The coordinate of origin is 0. On the right of the 0 there are positive numbers. On the left there are negative numbers. Now first we will show root 2. So here we have to do the geometric construction. Now see here, suppose the coordinate point A, suppose this is point A and its coordinate is 1. Okay, now draw a perpendicular to this lumbar line at point A. Okay. Now take 1 unit distance in the compass, in the point of compass, in the point of pencil. Okay, this is 1 unit distance. Now put the point on A and draw an intersecting arc to this perpendicular. Okay, now this is, now if you join this here, here we get a right angle triangle. This is 1 unit, this is 1 unit. So according to Pythagoras theorem, the hypotenuse will be root 2 unit. According to Pythagoras theorem. So now that means this distance is equal to root 2. So take the same distance on number line. So here is root 2. And suppose this point is P. Now at point P, again draw a perpendicular line at point P. Okay. Now again take 1 unit distance. Put the compass point on P. Draw intersecting arc. Draw intersecting arc to this perpendicular line. And draw this right angle triangle. Now this is another right angle triangle. According to Pythagoras theorem, this is hypotenuse. So here this length is root 2, base is root 2 and height is 1. And using Pythagoras theorem, you can calculate this length as root 3. That means this distance is equal to root 3. And take this distance on number line. Okay, this is root 2, this is root 3, so here is root 3. And suppose you want to draw root 4. Root 4 means 2. Square root of 4 is 2. That will be here. Again, if you want to draw root 5, then I can draw perpendicular at root 4. That means at point 2. And then complete the right angle triangle, and by the same procedure you can show root 5 here. Now if you want to show minus root 2, now this is distance equal to root 2. Now minus root 2 will be on the left of 0 at the same distance. So here is minus root 2. Suppose this point is C. Now if you want to show minus root 3, so that is this is minus root 3 and minus root 3 on the opposite of root 3, that means on the left of the 0. So here is minus root 3, and suppose this point is B. So in this way you can show this root 2, root 3, root 5 and so on the number line. Already you are studying this method in 8th standard.